For this last section where we're doing reinforcement learning using a graph database for our RAG implementation, we're taking a look at what reinforcement learning is in this particular context because it differs quite a bit from vector databases. Based on the previous sections, we've learned that when we query a RAG agent using a graph database, we obtain all of the context relating to that particular query, which is one of the special features that a graph database can provide us. And we use the context or those documents as the source truth to pass into our LLM. The LLM then uses that source truth or that context or all the documents that have been provided, and it looks for the answers within those documents and not within the data set that it was trained on. This provides safeguards and bumper rails for the LLM to only look at the documentation or information provided in order to find the answer. So we're going to start this demo off where we've already ingested our data set based on a bunch of tech articles from the British Broadcasting Company. And to demonstrate this reinforcement learning, we're going to offer up 5 particular points of data, and we're going to decide which ones we're going to accept into our short-term memory. So let's go ahead and do that right now. So we have our first fact here, and we're going to decide whether or not we want to ingest this, and it's an article relating to OpenAI. And we're going to ingest this into our short-term memory, so we're going to type yes and store this fact for 24 hours. We're going to skip this next one, and we're also going to ingest this one because it also happens to relate to Microsoft and OpenAI. So let's go ahead and ingest this and store this in our short-term memory for 24 hours. And we're going to pass on the next 2. Now what's happening here is we're basically have predefined questions that relate to each one of those articles. And we're going to query our agent to determine whether or not that particular fact is now in our short-term memory. And you can see here, for our fact 1, you can see that we actually have a question related to how much did OpenAI pay for windsurf. And we also entered our third fact into our short-term memory, which is relating to the article of OpenAI and Microsoft. Note that we didn't get any hit for the question relating to the data that we did not enter into short-term memory, which is fact 2 and fact 4 and 5. So this is proof that we actually have information relating into our short-term memory. So for the second part of the demo, we're going to actually force an expiration of our third fact, which is the article related to OpenAI and Microsoft. So we're going to go ahead and run this script now to simulate that process. So here you have the article where it discusses how much OpenAI paid for windsurf. And we're going to explicitly now take this short-term memory factoid and move it into long-term. And we're going to do that by typing yes right here. And as you can see here, the third item that we had entered into short-term memory, we're going to let this expire, and we're going to simulate the expiration of this 24-hour expiration period by typing expire here. So now we're going to retake those questions and retest our factoids to see what information is contained between our RAG agent. And you can see here, for our factoid 1, which is how much did OpenAI pay for windsurf, you can still see that the information is right there. Now for the third fact, the one that we simulated the expiration on, you can see here that there's no information relating to any kind of revenue agreement that OpenAI and Microsoft came to. The only context that it has is the OpenAI windsurf documentation, and this answer is actually correct. So here you can actually see a demonstration of a RAG agent backed by a graph database where you can do long-term and short-term memory with expiration so that you have the ability to phase out information that might be old or stale, and you have the ability to also take that memory and move it from short-term into long-term storage. I hope you enjoyed that demo.